All right, so today's lesson is on similar solids.
You think it's George?
I think it's George. So these are notes for 1111. Isn't that a lucky number? Don't you guys do something at 1111? Make a wish, that's it, right? So make a wish over your homework. Oh yeah, you could wish it to disappear. It's not going to happen. That's hilarious. Okay, so similar solids, and you see some pictures down here of some solids that appear similar. You can't go based upon appearance sake. You have to do some testing, and you have to do some exhaustive testing. In other words, you have to test every dimension that they give you. You can't just take one dimension and test it. And so similar solids have exactly the same shape. Let me take my bracelet off. It's going to create issues. But not the same size. So similar solids are like a dilation, but in the 3D world. Two solids are similar if and only if the ratio of their corresponding linear measurements are equal. So the ratios are equal. So the ratios, if you remember, ratios are called scale factors. So we're using the dilation information here to kind of test to see, are the solids similar? You can't just go based upon your eyeballs. And then some types of linear measurements that we might run into would be length. So you can compare lengths, width, bless you, height, slant height, and again. Perimeter, radius. You're blessed for the period. Diameter. Circumference. What do all these have in common? Length, width, height, slant height, perimeter, radius, diameter, circumference. They all have numbers. What else? What are they here? Is that what you said? What about their units of measure? Because you notice that surface area is missing there, volume is missing there. What do you know about all of these linear measurements? Right, they're all units to the first power. So that's what we mean by linear measurements. They would have to have units to the first power to give you that scale factor or that ratio to determine whether the solids are similar. So very important, look at the directions, determine whether the solids below are similar. If yes, give the scale factor in simplest form. So you can't just give it in any fraction form. You have to give it in its simplest form. So your calculator is going to be handy, so grab that. And I'm going to show you a little button on your calculator that you're going to be thrilled about. Might as well learn it. So on here, for number one, we've got, what is this measurement called? The height. And then we also have the height over here, right? And what do we call this the width, and maybe this the length of the base, and the width and the length of the base there. We have to test every dimension that they give us. So I cannot just test, well, first of all, because I have to have comparative purposes. So I can't just take these two and compare them to these two, because it's possible that their lengths aren't in the same ratio. So if they give you 3 linear measurements, you've got to test all 3. So we're going to start with, and I typically go from left to right. So I'm going to start with my height, and I've got 12 is to 3. And so that's this height is to this height. And then that should equal if they're similar. The widths to each other, so from left to right, I'm going to go 8 is to 2. And that should equal the lengths, which are 20, is to 5. Then you have to reduce each of those fractions and show that, just like when we did similar figures, when it was just two-dimensional, we have to show that all of those ratios are equal. So what does 12/3 reduce to as a ratio? Yeah, so this is 4 is to 1, 4 over 1. We want to write it as 4 over 1, so it's that ratio. What about 8? 4 over 1, and then 20 over 5? That is also 4 over 1. So since they're all equal, your answer is going to be yes. And then they want the scale factor, so the scale factor is going to be written this way, 4:1. Because they want the scale factor in simplest form. Now, if you had gone right to left, your scale factor would read 1 to 4, and that's okay. So typically, if you're taking a multiple choice test, and I just say that for Arizona Merit's purposes, because part of their test is multiple choice, if they say you have to give your scale factor from big to small, then it would be 4 to 1. If they said give your scale factor from small to big, then you'd flip this around, it'd be 1 to 4. So when you're doing the Arizona Merits, just keep that in mind. If there's no information given, like this tells you no information as far as that goes, then don't worry about it, just go left to right. So let's do the same thing for 2. So they give us 3 dimensions. We have 2, well, it looks like squares here, right? So 6 is to 10, 6 is to 10, and then 8 is to 12. So we have to look at all of those. So let's set up those ratios. From left to right, 6 is to 10, as 6 is to 10, as 8 is to 12. So if we reduce 6/10, what does that reduce to? What goes into both 6 and 10? 2. So 2 goes into 6 3 times. 2 goes into 10 5 times. So same thing for the other one's going to be 3/5. What goes into both 8 and 12? Biggest number, 4. So 4 goes into 8 twice. Oh, that's a problem, right? And 4 goes into 12 3 times. So these are equal, but this is not equal. So are these similar solids? No. So then let me show you a little handy button on your calculator. So look on your calculator for a button, and this button is used to reduce fractions. So look for a button that says A, B/C. Everybody have that button? If you have a graphing calculator, it's underneath your math menu. And so I can show you how to do that later, but for my purposes, because you're using my black calculators, you won't be able to use those graphing calculators. What about the display calculators? Anybody have the smaller TI displays? Can I see yours for a minute? Thank you, Jack. You have that button, right? Or is it different? Oh, yeah, it is. All right. So everybody has that button except for the graphing calculators. You don't have that button. So what I want you to do is I want you to take on your calculator 6 divided by 10, hit equals, and then, oh, that didn't work. Let's try it this way. 6 button, oh, okay. So you have to do 6. So on your calculator, you're going to do 6. Then you're going to hit your A, B/C button, and then you're going to put in 10. And hit equals. Didn't it reduce it for you? Right? Those of you who have the calculators, did it work? No. Well, yes, they do. The graphing calculators don't. Well, they do. It's under a different menu. So if you have the graphing calculator, go what I want you to do is put in 6 divided by 10. So if you have the graphing calculator, 6 divided by 10 equals. And then you're going to hit math. The math is on the left. You can see the math key. And then you're going to hit enter, enter. You have to hit enter twice. Did it give you 3/5? Right? So write down, if you have a graphing calculator, write down math, enter, enter. So, but you have to have the decimal equivalency first, and then you hit math, enter, enter, and what it does is it's telling your calculator to take that decimal and convert it to a fraction in simplest form. So on the graphing, it's math, enter. I'm abbreviating that, enter. Yep, math, enter, enter. Okay? And that'll give you reduced fractions, which should help reduce your work, but you still have to write the fractions out. Now, when you look at number 3, this dimension is what to the cylinder? What's this dimension? Diameter. What's this dimension to this cylinder? So now they're trying to turn it so that, you know, it's hard for you to tell, but that's the radius. What would be the diameter on this one? Yeah, double it, you're going to get 20. So when we write our ratios for all of the pieces that they've given us, for the diameters, I have 24 is to 20, if I'm going from left to right, and we're going to compare that and see, is it equal to the height on the left one, which is 30, to the height on the one that's turned sideways, which is 25. So practice on your little calculator, the new button, right? So for most of you, you're going to do 24, the mixed number button, 20, and hit equals. And so on this particular one, it gives you an improper fraction, doesn't it? It gives you 1 1/5. So what you're going to do you see above this key, do you see a key that says in a color D/C? Right? So you're going to change it to its improper fraction by doing seconds, and then hit that A button again, A, B/C button, and you get 6/5. Do you not? Okay. If you have a display calculator, it's not an issue for you. If you have a graphing calculator, it's not an issue for you. When you did math, enter, enter, it came out with 6/5 immediately, did it not? Okay. But those of you who have just the scientific calculators, just the display calculators, when you do this and hit equals, you're going to get 1 1/5. So then you have to do second, hit this button again, and it will immediately change it to 6/5. Just learn to love your calculator. So those of you who are not using the scientific calculators, when you go to use my calculators on your test in a couple weeks, you better know how to do this, so I'd study it, or use somebody else's that's like that so you get used to doing it. Alright, so then let's put in 30, hit your fraction button, and then 25, and hit equals, and then again you get 1 1/5, which also is 6/5. So this one we only have 2 dimensions, so that's all we can go by, and there's really only 2 dimensions on the cylinder anyway, radius and a height. And so are those solids similar, yes or no? Yep, so yes they are. How are you going to write your ratio? 6:5. That's it. So that's pretty much what we're doing, but we're going to add just a little bit to this. And what if they give you volume or surface area? Or you have to find a solid's volume or surface area. It's so easy to find a solid's volume or surface area if you already know that 2 solids are similar. All I need is all I need is 2 things. To be told that the solids are similar, which you'll read that in the directions, and then all I need is 1 set of linear measurements. If I have 1 set of linear measurements, then the following is true. So if 2 solids are similar with a scale factor of, what color? A scale factor of A to B. So that's what we just was busy finding, was a scale factor of A to B. Then their volume and surface ratios are as follows. So their volume ratios would be A cubed is to B cubed. Why does that seem reasonable? What do you know about volume and their units of measure? They're cubed, so that makes sense. And then surface area ratios, what do you think are going to be? A squared to B squared, very good. So how does that help us? Look at number 4. They tell you in the directions. Identify the scale factor for each pair of similar solids. So we don't have to figure out if the solids are similar. They told you that they're similar. So that means I know that the scale factors are going to be correct. So you can just pick to compare the heights to each other, or the bases to each other, or these widths to each other. I like the height 6:3. So I'm going to take and figure out my scale factor. 6:3, and I'm going left to right, and then that reduces to 2:1, doesn't it? So if my scale factor is 2:1, what is the surface area ratio going to be? Yeah, so we're going to square each one of these. So 2 squared is 4, 1 squared is 1. The volume ratio? What's 2 cubed? 2 times 2 times 2 is 8. 1 cubed? 1. And we could go through and actually find the surface area and the volume of these, and they will come out to be those ratios. Guarantee it. All right, so let's look at... So this time they've given you 2 cones. You have a choice of comparing, and again, they're similar because I told you. You can compare the radii, that was terrible. Or what are these called? The slant heights. Which one looks nicer to compare? Yeah, the radius. So we're going to do 4:6. And that reduces to what? 2/3. So our scale factor, is 2:3. And then our surface area ratio, what are you going to do with the 2 and the 3? Well, you're not going to times it by 2, you're going to square them. There's a huge difference between that. So 2 squared is 4, and 3 squared is 9. So if you had multiplied them by 2, you'd have 4 and 6. So just be careful that you don't do that. Okay. And then the volume, what do you get for volume? What's 2 cubed? 8. And what's 3 times 3 times 3? 27. How hard is that? Not difficult at all. Okay. The only tough part, if you will, is when they give you the surface area of the volume, so you might want to highlight this. So please highlight this. When given the surface area or the volume, always find the scale factor of A to B first. We're going to find this scale factor first. So in this case, they've given us surface area. So if I have surface area, I'm going to write my ratio is 25:4. Bear in mind, this is my A squared, and this is my B squared, right? So what would A to B equal? What's the square root of 25? 5. And what's the square root of 4? 2. So you're not going to reduce that fraction. Well, you could reduce it before you take the square root of it. And in fact, you might have to. But in this case, you can't reduce 25/4. And so we get our actual scale factor is 5:2. They gave us the surface area already, so we'd have to figure that out. That's 25:4. So what's going to be your volume? Discuss it with your table group. Find your volume. Scale, or your volume ratio. Do y'all have it? All right, so let's freeze. Allie Miller, what did your table get? So volume should be squared or cubed? Cubed. So what is 5 cubed? What'd you guys come up with? No. Clear out your calculator. And then just do 5 caret or 5 why to the X button, 3. And what do you get? There you go. So the 5 cubed is 125. I don't know, how'd you guys get such a big number? Oh, did you take the 25 cubed maybe? Oh, okay. You have to take, it's always going to come from, like here, you're going to cube it. A cubed to B cubed. And I can't get my cube in there. Almost. Does that make sense? And so what is 2 cubed? What's 2 cubed? 8. But, you know, that's a common error because you're like, oh, okay, I've been taking what I started with and just squaring and cubing that. Now it's just a change in rules to our head. All right, so look at 7. This time for 7, they gave you volume. So if they give me volume, I'm going to do left over right, so 162 over 384. They're both even numbers. Since they're both even numbers, you want to reduce that fraction, which is why I showed you the button on your calculator, because that's an ugly fraction I have to reduce. So you're going to put in 162, hit your fraction button, and then 384, and hit equals. What did it give you? 27 over 64. Then you need to find, since this is volume, how do we get from, remember this is A cubed, and this is B cubed. How are we going to get to A to B? Not the square root, but the cube root. So I have to find the cube root. So on your little calculator, you have, you should have, look above the, let me move this over so you can see. Look above the key that looks like this. Above your y to the x key, in a different color, should be an x root of y. Do you see that above this key? So if I want to find the cube root of 27, and on your graphing calculators, it's probably under your math button. Okay. So then you're going to put in 3. So you put in your root first, 3, then hit second y to the x button. Oh, no, that didn't work, did it? Let's try this again. Put in your 27 first. Maybe. I have to play with it. That did not work. Alright, let's try it again. 3, button, 27. Nope. How about 27, button 3? Aha. Alright, so you're going to put in your 27 first. So you're going to do 27. Then you're going to hit second. Then you're going to do the y to the x button and then 3. So 27 second, y to the x button, 3, and you have to hit equals. What'd you get? Let me see your calculator. I wrote out, well, okay, because you have a graphing calculator. On yours, it's different, so we'll have to talk about that. So, I know, but you don't put yours in the same way as I do. So those of you with a scientific, well, probably not. I'll have to look. Oh, okay. So you got to put on the scientific, you have to put the 27 in first, so clear out your calculator. Put the 27 in first, hit your second button, then hit the y to the x button because that's probably what it's above. It's probably what this is above that button. And then put 3 because you're putting in the root. So this is the base. This is telling the calculator you want to take a special root, and then you're putting in the 3 for the root, and then you have to hit equals, and it should give you 3. The cube root of 27 is 3. If you take 3 times 3 times 3, don't you get 27?
Yes.
Right? So then we get 27, or I'm sorry, 3 for the cube root of 27. Find the cube root of 64, please. Do the same thing, but this time you're going to do 64, second, y to the x button, 3 equals? What'd you get?
4.
4 is correct. So that is just our scale factor. 3 is to 4. Then, now you're going to use that scale factor to find all the missing pieces. So if I want to find the surface area, you're going to do something with that scale factor. So talk amongst your table groups and find the surface area ratio. You already know your volume ratio. Stop. Stop. So talk amongst your groups. Find the surface area. All right. Let's see what we got. We're on number 7 still. All right, so Jack, what'd you guys get?
16.
9 to 16. So 3 squared is 9, right? And 4 squared is 16. That's correct. Oh, is that what you're saying, Kristen? Gotcha. A little delayed reaction. All right, in your table groups, I want you to find number 8. This time they've given you surface area, so it's just like 6 or 7. Just like 6 or 7. Which one? Just like 6. So follow along with that. Don't look up here. I'm going to quietly do it on my own. All right, so look up here. If you take 960 divided by 375 and use your fraction button, you should get a reduced fraction of 64/25. Then from there, because that's a squared over b squared, because it's surface area, take the square root of 64 and 25. Don't you get 8 and 5? Agreed? So 8/5 or 8 to 5 is your scale factor. And if you square 8, you get 64. Square 5, you get 25. How are you going to find your volume? 8 cubed and 5 cubed. So, what is 8 cubed? 512. And what is 5 cubed? 125. Now, couldn't we use those volume and surface area ratios to actually find surface area and volume without going through all the formulas that we've learned over the last 2 weeks? We could. We absolutely could. So let's look at some application problems. We only have 4. So for number 9, solid A is similar to solid B, so that's important. You're driving me crazy, stop it. Because that's going to all come through on my video, so knock it off. So solid A is similar to solid B. The ratio of height of solid A to height of solid B is. So we've got height of A is to height of B. And they've given us 7 is to 3. I'm going to write it as a fraction. Find the ratio of the volume of solid A to solid B. So our volume of A to B is going to be what? What do we do with that? Is it going to be A to... So think of the fact that is it just A to B? Or is it A squared to B squared? Or is it A cubed to B cubed? A cubed to B cubed. And so right here, isn't this one equal to A to B? Agreed? So all we have to do is cube them. What is 7 cubed? 343. And what is 3 cubed? 27. So that's our answer right there. That's all they're looking for. Then number 10, now we have a cone. So cone A is similar to cone B. The ratio of the surface area of cone A to cone B is 16 to 1. So this time we have surface area. Surface area of A, surface area of B is equal to, I guess I want, that's all right, is equal to 16 to 1. And so isn't surface area equal to A squared to B squared? So they want the ratio of the radius of cone A to cone B. The ratio of the radius is going to be the same as A to B. Because remember, radius is a linear dimension. Radius, length, width, height, perimeter, circumference, all of those are linear measurements. So if I can reduce this to A to B, I will have my answer. So if 16 is A squared, what's A? 4. And if B squared is 1, what's B? 1. So there's your solution. It's that easy. The ratio of the radii of cone A to cone B is going to be 4 to 1. And then for 11, cylinder A and cylinder B are similar. If A has a diameter of 24, is that a linear measurement? Diameter, yep. And cylinder B has a diameter of 30 feet, so let's put diameters, that's A to B. And so they've given you 24 is to 30. And they've told you that they're similar, so I can set those as a ratio. What is the ratio of the volume of A to B? Is that a reduced fraction? Those are not perfect. Well, is that fully reduced?
No.
24 to 30? Nope. Things divide into those. So find the reduced fraction of 24 to 30. What do you get? So 6 goes into 24 4 times, 6 goes into 30 5 times. So A to B is 4 to 5. If I want to find volume, what is that? Is that A squared to B squared, or is that A cubed to B cubed? All right, so we have to find A cubed to B cubed. So what is 4 cubed? 64. And 5 cubed? 125. And that's your answer, 64 to 125. And you can write it as a fraction or as a colon, it really doesn't matter to me. And then this time I want you to discuss with your table group how you're going to do 12. You've got 2 pyramids are similar, they've given you the volumes of both of them, and they want the ratio of the surface area. So if we need surface area, we have to have something in order to do surface area. So use the volume to get that something in order to find surface area. You are going to run into a little issue. What's your issue if you have the little scientific display calculators? Did you notice anything? If you try to put in 648 and you hit your fraction button and you put in 1029, what happens? Did you pay attention to that? Can you put in 1029? Your display is not long enough to get the 9 in there. So it is only taking 648 and dividing it by 102. So your reduced fraction is not 108 over 17. It is not. So you're going to have to do a little bit of thought processes by hand. What goes into 648 and 1029, do you think? Are they both even? Yes or no? No, so 2 doesn't go in there, right? Use your 3's rule. Does 3 go into 648? Add up 6, 4, and 8, what do you get? No, 6 plus 4 plus 8 is not 12. 18. All right, so 18 is divisible by 3 and 9. What goes into 1029? What's 1 plus 0 plus 2 plus 9? 12. 12 is divisible by 3, but not 9, so both of these are divisible by 3, so let's start there. 648 divided by 3 is 216. And then 1029 divided by 3 is 343. Haven't you seen the number 343 before? Right? Perhaps that's a perfect cube. I don't know. Let's see if they are. So now take those buttons that we were talking about earlier, and you're going to take 216. So 216 second, Y to the X button, and then 3, and hit equals. Wow, didn't we get 6? So let's see. Our A to B is equal to 6 over. Then find the cube root of 343. So put 343 second, Y to the X button, 3 equals. And we get a 7. Now what do we do with that? Very good. So we're going to square that. So then our A squared over B squared is equal to 6 squared is 36, 7 squared is 49. So our answer is 36 to 49. Why did I not get there? Oh yeah, I did get their answer. It's getting a little concerned. All right, so any questions about that? So if you didn't pay attention to your display calculator, and especially if you have the smaller, the ones that I give you, some of those ones that you guys have that have the nice display on it, it's the scientific with the display, you probably were able to get the 1029 in there, right? But not if you have my little black ones. It didn't fit. So do be careful, make sure you're watching what your calculator is doing. Are there any questions on this? How easy is this? Simple, right? Okay, good.